Hello friends, I am Vijan Very. All are welcome to my YouTube channel. In this session 26 video on railways, we will have a detailed look into points, crossings and turnouts. It is always a mystery for the ordinary man how a train takes diversion, whether it is possible for the driver of the train to take such a diversion. Is it he doing it or is it somebody else? The driver of the train can only increase the speed, decrease the speed or stop the train. But it is the station master who is doing the steering part of this driving. It is the station master who is deciding on which line the train is to be received, on which platform the train is to be received. So there is a vast difference between running a road vehicle and running a train. On viewing this video, you will get all these doubts clarified. Now we will go to the diagram. We have mentioned this term points in several places in the earlier videos. That is points set for main lane, points set for loop lane, etc. So now we will see the points in detail and also the allied mechanism. Here you can see there is a straight line, that is the straight track. And from this straight track, a line is branching off. And this branching of line is called a turnout. So this is a turnout. This turnout can join another track or it can go straight to another line. So we will see what are the portions of this turnout. Now a turnout will have definitely a switch and a crossover. What is meant by a switch? Switch is a mechanism by which you can alter the direction. So here a switch is used to alter the direction of the train. Here a train coming from this direction can be directed either to this direction, that is towards the turnout, or it can be directed towards the straight line. So the switch is used to alter the direction of this train. Then we will see how this switching mechanism works here. Here you can see this is a piece of rail and this is another piece of rail, and these two pieces of rails are connected by a rod, and that is called a stretcher bar. Stretcher bar ensures that these rails are joined together and these two pieces of rails will move only together. So it is called a switch. So this switch can be either moved towards this direction, towards this rail, or this can be moved towards this direction. Now this is moved towards this direction. These two rail pieces are called tongue rails. So one tongue rail and another tongue rail. These two tongue rails are connected here with a stretcher bar. So we can say a switch is composed of two tongue rails connected with a stretcher bar. The end of this tongue rail, is called toe of the tongue rail. Toe, T-O-E. The portion of the rail which is very close to this tongue rail is called stock rail. So here we can say this portion of this rail is stock rail. Here this portion of this rail is called stock rail. Now this portion is called the point, and here also the points. As in the case of scissors, we are not calling scissor, it is scissors because there is a pair of it. In the same way, here is one end which is getting close to the stock rail. Here also the other end which is getting close to the stock rail, and so we call it points. It is points, not point, but it is points. Point is said to be normal when it is set for the straight line. Here you can see now the point is set for the straight line. The train coming from this direction will go only in this way, in this condition, when the point is set like this, or the tongue rail is close to this whereas the tongue rail here there is a gap. When the point is set for the turnout, then we will say the point is reverse. In that condition, what will happen? This switch will move towards this direction. The tongue rail will be close to this stroke rail, and here there will be gap. The train will go this way. So now we will see how it is possible with the wheel of the train. The speciality of the wheel of the train is flange here. Compared to the other portion of this wheel, here it is a big diameter, and you can see the wheel is kept within the two rails. Any push on either side, the wheel will not go out, because the flange will prevent this wheel from going out. So that is how the wheel is constructed. Here it is the axle. From the flange you can see it is gradually decreasing. The construction of the wheel is such a way that there is a flange towards the inner side. Here the flange, here the flange. The wheel is prevented from going out of the track by these flanges. So this point is set for the main line. While the train is moving through this line, what will happen? The wheel flanges is inside the track, here inside. So this will go in between this tongue rail and the stroke rail. In between the tongue rail and the stroke rail there is a gap, and the flange will move along this side. Whereas here there is no problem, it is close to this stroke rail, so it will move in this way. When the switch rail is moved or operated in the reverse position, what will happen? This will touch like this, whereas here there will be gap. Whereas here there will be gap. So when the point is operated, the switch will move towards here, and here the tongue rail will touch the stroke rail, whereas here there will be gap between the stroke rail and the tongue rail. And so when the train is coming this direction, the wheel flange will go in between this stroke rail and the tongue rail, and so the train is forced to move in this direction. Here a pair of the wheels are fixed in the axle, so it will not rotate separately. The entire structure will rotate. Here this switch can be operated locally by a lever, or it can be operated from the station. By operating this machine from the station, this switch can be freely operated towards normal or reverse. We will say this point is interlocked when it is connected with a signal. That is, by taking off that signal, whether it is shunt signal or a stop signal, we will ensure that this point is locked. Now in this position, by operating the machine from the station, only setting of the point is ensured. Now the point is set for the reverse. So the point is only set. Now it is to be locked. How it is locked? Locking is ensured by operating the concerned signal connected with these points. So when the signal is taken off, that means the point is locked. So here the shunt signal, it is in on position. Now the shunt signal for a train towards this direction is taken off, means two oblique white lights will burn. So the shunt signal is taken off. That means this point is now locked. Locking is normally ensured through the taking of the signal. So if the signal fails, what happens? That means the point is set but it is not locked. In that case, we have to physically lock the points. In this condition, we will lock the point at this end, where the tongue rail is touching the stroke rail. That portion will be locked. This end will be locked using clamp and padlock or quarter bolt and padlock. In the yard, suppose this point is in the yard, it can be set by operating a lever. It can be set. But how it is locked? It is locked by using quarter end, and it will be padlocked. Whereas in the case of points interlocked with signals, if the signal fails, whether it is shunt signal or it is a stop signal. If it fails, what will be done? This point will be locked physically by clamp and padlock. It will be clamped, then that clamp will be padlocked. That means for movement of trains over points, that points must be set as well as locked. If it is not locked by taking of the signals, it should be locked locally by quarter bolt and padlock or clamp and padlock. Depending upon the direction of the train, points is said to be either facing or trailing. Here, suppose a train is coming from this direction. This train will first face the toe of tongue rails. Toe of tongue rails will be what the train will first face. In that case, the train is said to be coming in facing direction, or the train is in facing direction and points is said to be facing point. Also, when a train can be directed to two routes, then also the point is called facing point. So a facing points can be distinguished from the fact that when a train is approaching the points, if it is facing the toe of tongue rails means the end of this tongue rail. So if it is facing the toe of the tongue rails, and also if it is directing to two routes, then it is called facing points. The other direction is normally called trailing direction. Trailing direction, it is actually where two roads will converge, two routes or two tracks will converge, then that point is called trailing point. Or for the train coming from this direction, this is a facing point, whereas a train coming from this direction as well as for the train coming from this direction, the points is said to be trailing. Now this has got a very much significance in railway operation. Suppose a train is coming from the facing direction, the points is set either for turnout or for straight line. Suppose the points has failed, and if it is not operated properly or if it is not set properly, what will happen? The train will derail here. In the normal course, the point is set here means the train will go to the turnout, whereas the switch is operated and this tongue rail is touching here means there will be gap here. That means this train from this facing direction will go in this straight line. So in any of the routes, the train will go if the points is set. But if it is not set properly, the train will derail. Now take the case of a train coming in the trailing direction. Suppose from the trailing direction, if the points is not properly set, or suppose the train is coming from this direction, the points is set for this direction. For the train, a train from this direction, this points is set. But a train coming from this direction, if it is passing these points, what will happen? The train will not derail, but the wheel flange here will push through between this stock rail and tongue rail, and this tongue rail will be damaged. But at the same time, here also this tongue rail will be damaged, but the train will go this side. No problem for the train, except that these points will be damaged. Both the tongue rails will be damaged. So in the trailing direction, there is no chance for the train to derail. That is the difference. In the facing direction, if the points is not set properly, there is a chance for derailment. Whereas in the trailing direction, if the points is not set properly, or if it is set for the other line, still there will not be any derailment. When the trailing point is not properly set and the train passed that points, damaging the trailing points, then this accident is called trail through accident. In trail through accident, when the train has passed partially these points, and if it backs, definitely there will be derailment. So a train which has trailed through should not back from that position. So that much about this facing and trailing points. Now let us come to the rail frog or crossover. See here, this much portion is called rail frog or crossover. Here at this point and this point and this point and this point, in these all four areas there will be fish plate joints. So this one is called the rail frog or crossover. A crossover will have a nose rail and also two wing rails. These two are wing rails and this is the nose rail. Here it is called the nose of the rail frog. Now what happens when a train is moving over this crossover? Let us see. Here the point is set for this turnout. Now when the train is moving towards this direction, the wheel, what will happen to the wheel? The wheel flange is moving inside. The wheel flange will be inside and the wheel flange will go like this. Here this wing rail and this rail will keep the wheel flange from moving out of the path, and at the same time here there will be guard rail, and the guard rail and the rail will see that the wheel flange is moving in between this, so it will not be shifted out or towards in. So guard rail and here this wing rail will see that wheel flange is properly moving within the space. Here while the wheel is moving towards here, we can see here there will be a drop, then it will be moving on this nose rail. Here you can see there is a small gap. Here in this gap the wheel will drop, and on the drop actually it will just give high pressure or high weight on this nose. So this nose should be very hard, otherwise there is a likelihood of it getting wear out. Now let us see, when a train is moving this direction, what will happen? From this there will be a small drop and the wheel will move in this direction. So here also when the train is moving in this straight line, also there will be a drop. This gap will be 3 to 4 millimeter, but still there will be a drop, and the drop will cause a heavy weight on this nose. So the nose will eventually wear out. To prevent the wearing out of this nose rail, CMS crossing or frog is used. Manganese steel is steel having manganese content. You know the stainless steel. Stainless steel has got the glittering because of the presence of chromium in it. In the same way, the presence of manganese in the steel in a particular quantity will have hardening of this steel. So that such hardened steel will be used for this rail frog, so that the wearing out of this nose will be reduced. This rail frog, this crossover is a very costly one. So if at all it is worn out, if at all this nose is worn out, it can be rebuilt. 4 or 5 times it can be rebuilt. After that this frog will be replaced with a new one. Previously this rail frog was manufactured from 3 or 4 steel pieces connected by nut and bolt. Nowadays these rail frogs are coming as a mold, so it is called cast manganese steel. This rail frog will be a single piece one, there will not be any joints, so such a molded CMS crossing will be long lasting. So that much about this rail frog. Now coming to the turnout, we used to hear the turnout mentioned as 1 in 8.5 or 1 in 12 or 1 in 16 or 1 in 20, like that. So what is meant by this 1 in 8 and a half turnout? Here you see this figure. See, this is the main line or the main track, and this is the turnout. Here this is the straight track, and this is the turnout. So here the points are there. Switch rail is here. Here this is the crossover. Turnout goes like this. Now in this turnout, here this is the nose rail. This is the end of the nose. From the end of the nose, in this straight line, in this straight track, you measure the distance. Suppose here you measure to 8.5 feet. That is, this straight track, this straight rail, from the nose you measure 8.5 feet. Here this is the turnout. This rail is near to this rail. Distance from this nose rail to this point is 8.5 feet. From this point you measure the distance to this rail. If it is 1 foot, then we will say this is a 1 in 8 and a half turnout. So this distance from this nose for this straight track is 8.5. From that 8.5 mark towards this turnout track, it is 1 foot. Then it is called 1 in 8 and a half turnout. Now take this picture. This is the straight track. In the straight track, from the nose rail, you measure the distance. This distance from this nose rail is 12 feet. Now the distance between this mark, that is 12 feet mark, towards this rail of this turnout will be 1 foot. So this is a 1 in 12 turnout. So what is the difference between these two? Here you can see from this nose rail, the gap between this rail and this rail is going on increasing. And at one point it will be 1 foot. In that case, the distance from this nose rail to this rail, this point will be 8.5 for the straight track, for the straight rail. So here it is, or here also the distance between this rail and this rail is going on increasing. This gap of 1 foot we will get only at a distance of 12 feet. Here let us see what will be the difference of these two turnouts. Here this turnout will be very sharp. From the main line it will be going very sharply, whereas this will not be having that much sharp. Here we can say this track is not having that much curve, that much bend. So what is the benefit? Here in the main line you can go at 100 or whatever be the speed, but in the turnout you can have only a speed of 15 kmph. Here main line you can have 100 or so speed, but in the turnout you can have 30 kmph, because the curve here, the bend here for this turnout is not that much sharp, that of 1 in 8 and a half turnout. Then coming to this turnout, here this is the straight track and here this is the turnout. This turnout is almost parallel to this track. You can see almost parallel. But for that you have to use very lengthy tongue rail. See, these tongue rails are very lengthy compared to these ones. Also this switch should be thick. So we will say it is thick webbed switch. Thick webbed switch will be used. You measure the distance from the nose point on this straight track. Only on getting 20 feet, there will be 1 foot distance from the turnout track. That means this is almost parallel to this main line. Here we can have a speed of up to 60 kmph. We are having this 15 and 30. 60 kmph speed over turnout is not yet introduced in Indian Railways, I think. but it is in the process of having such a turnout. This much about the turnouts. Okay, now I think you have got several of your doubts clarified through this video. Anyhow, if at all you are having any doubts regarding the matter dealt in this video, you raise those doubts in the comment box. We will discuss those doubts and we will get those doubts clarified. So, till we meet in our next video, bye.